Okay, we're back again. We're going to continue on with this joystick tester project that we started last time. Just as a, I should have mentioned that I thought I'd take a break from 7.4 HC595s and from Pong games and things like that. Though I was supposed to actually finish up the Pong stuff tonight, but I got caught up reading a book. So that's how things happen. But anyway, I've put these little LEDs down, and we haven't finished putting them all together yet, but we're going to do that now. And then we're going to go through making a simple setup so that we don't need this thing here, and that we can run it off a 9-volt battery, but we're still going to try and get 5 volts going across here, because according to the specifications it requires 5 volts to go through here. And I think if you want to get the auto fire to work on the joysticks, you're going to need 5 volts to go through there, but we're not going to do it exactly 5 volts, as you'll see. But first, let's just quickly get the basics working. So from yesterday, I just drew this up today to sort of explain how it all works. So you've got 5 volts coming in here from the computer generally, and it's going into the different pins on this thing here, and inside basically you've got these little switches. So I'm just drawing this diagram in case it wasn't entirely clear how the inside of a joystick works. I wanted to take one apart, but I don't think, well, if we have time tonight we'll do that. But basically there's 5 buttons on the inside. There's the up and down buttons, left and right buttons, and the fire buttons. I've gone through here, so on here it does actually tell you what these things are. So I thought about it afterwards. It's like, well, I was all saying how wonderful this book is, that it tells you everything you need to know about this computer. I'm running out of room on this desk here. Let's move those back to there. But then again in the picture it just says, if you can see it, it just says joy A0, joy A1, joy A2. It doesn't really tell you much, but a few pages back it does actually tell you that up is switch 0 and left is switch 2, and so on and so on and so on, and even gives you some old school basic programs to read in your joystick, and you can get that kind of stuff. And a really cool thing actually about these joystick ports on a Commodore 64 at least is that they can actually be used as input and outputs. So at some point I want to see if this is actually true, because I've never done it, and see if I can program the Commodore 64 to output stuff and then actually connect something up to that and interface with the Commodore 64 that way. I'm going to have to get a working Commodore 64, so there's going to be a video. I do have a working one, but it's in a box and it's pristine, and I have a semi-working one which I probably will use, but I have a couple of them and most of them don't work properly. But we're going to go through and try and repair one by replacing the capacitors probably. One of them requires a specific RAM chip replaced, and I think I can actually pull that one off, but it will be quite tricky. So anyway, this is how it works, and these are actually the pin numbers. So I wrote in red what the pin numbers are on this thing here. So with this, and without the book for a second, I'm going to use this to quickly wire up the remaining wires. So according to this, we need 1, 2, 3, and 4, and 6. So where did I put that screwdriver? I hope I haven't lost it. And that will all be, I actually put these little things on, but if I'm not paying attention to what I'm doing, I thought I'd start putting little beads on, because when you get these little projects, they get kind of complicated, and it's very hard to keep track of what you're doing, I find. So the big problem with the Pong thing is it's a big mess, and well, it's mainly the buttons. So before I go any more on the stuff, I'm going to rearrange the buttons on that one a little bit. This one's got 2 orange things on it. I could just use different coloured wire, and I'm slowly accumulating stores of various colours of wires. So that's all stuck in there. So those are the 4 joystick directions, and then we're going to need 1. These are all the wrong size, aren't they? Like, this is the worst size thing. But I mean, in the end, of course, I'm not going to use this kind of stuff. I'm going to use just a little one like this and solder things directly in. I would have shown one, but I don't have. I forgot to get it out. And stick it in a little plastic container and solder it all up. So it should be all pretty straightforward. So this is just meant to be an initial first quick project, and I've got the perfect plastic containers to attach them to. So I'm going to use one of these kind of plastic containers just for fun. So I'm going to put some holes in the top and put the LEDs in the top, and everything can go on the inside. Alright, so let's just do this quickly, as I've been saying over and over again. So this is going to be, I'm going to do it, so this is the button goes up here, so this is the top. So looking over here, I want this one to be up and down, and then I want this to be right and left. I'm guessing that's correct, but I'm doing this upside down, so I'm assuming that's actually your right, and this is your left. So let's go with that. So we'll start with this one, which is, I'm just double checking, it is the left. So this was pin number 2. No, it's pin number 4. So I've got to read what I wrote. No, wait, that's 4 for that one. So the red one goes there. Okay, so this is 3 for left. So that's the one with little orange things on it. It's going to be a bit tricky. So there we go. And 4 was right, which is kind of good, because the wire's got to go all the way over to there. So I did it so all the LEDs have their short legs going that way and their long legs going that way. So the positive side's going this way, the anode or whatever, and the cathode's going that way. So I don't have to worry about taking them out and checking. But I could get it wrong, of course. You never know. There's always a very good chance, like a very, very good. And this doesn't look right. So that one was actually the joystick one. Alright, it's going to be a mess, isn't it? I feel like I should have really thought out the ground a bit better. We still have to also attach the positive 5 volts to get this to work. So this one is the right one. So get that one correct, not right. And that's looking okay. And then this one is, so looking at the picture which you can't see, so 2 is down, so that one can go to there, and then 1 is up. So hopefully this is all wired up. And then we're going to use a couple of these 470 ohm ones. Well, a couple. We're going to use 4 of these. So we're going to make it a bit dimmer, because I think I'm pushing these resistors a little bit sometimes. And we're just going to put these, how am I going to do this? Straight to 5 volts. So they're going to go straight to the 5 volt rail. We're not going to do any nice little things like that. So these things can just come out, because we're just not going to muck around. Otherwise it's just going to be a humongous mess. And it's already a humongous mess. But it will look so much nicer. That's the nice thing about soldering things up, is that generally even they just look better. They look kind of cool. I actually quite like. I like these old. I like old electronic stuff because they're big, and it seems impressive when you. Is that if I got the little sticky stuff off the end there? I don't think I have. All right. It just has a nice sort of feel to it. So one of the points of this channel is I feel like it should be a kind of like up there with crafts. So that you're making these little bits and pieces, and they have a kind of stylistic appeal to them, and that's sort of important to appreciate. And so, you know, modern electronics is one thing, but old clunky big electronics is another, and it's nice. I like it. How come this one's not wired? It is wired up. All right. And then this one goes to there, and we've got one. No, we've got one extra one of these. Okay. So I should have cut the legs down, but I didn't. So I'm going to get my joystick, which doesn't have fire. Where's the other one that does have fire working? Because we're going to need this one. So we're going to get my giant joystick, which I wasn't going to take this one apart. You can kind of see everything on the inside. It's got 2 switches. This one here is, so another computer that used this kind of joystick is the Amstrad CPC. And that has some strange quirks with auto fire. So at one point I'm going to take this apart and see what the actual circuit is, and I'm going to look up why CPC stuff needs a special case for the auto fire. I think it's to do with the funny way that it had this little thing where you can, if you had two joysticks together, you had to link one to the other one. And strangely, I went and sold my only Amstrad joystick that does that recently because I didn't think it was that interesting. I don't know why. I kind of regret that now. And another computer that did this was the Sega game consoles. So it was Sega Mega Drive and your Sega Master System or Genesis. And they have a slight quirk which is slightly different to this. So there's one pin that's different, I think, and causes it to be a problem sometimes if you plug it into different computers. So at the moment we're just focusing on the really simple ones. So we've got that working, and we're going to plug in that joystick which I've just had, and then I've gone and put it away somewhere. That was clever. Like, I can't lose that. Okay, here it is. Like, how could I possibly have lost this thing? It's so big. Alright, this needs the lid. I don't want to lose those. I've got quite a few. I think it's quite nice to have your resistors of different types and brands and colors, because then it's very easy to pick them out. Alright, so activating this now, and we're going to test. I'm going to press up, so that works. Press down, that one works. Left doesn't seem to work. Right doesn't seem to work. And the top fire button does work fine. What if I turn the thing on? Nothing happens. Okay, there's a little switch on the top. That doesn't do anything yet, but I'm wondering when we connect up to 5 volts, it might. It's going a bit strange there. So is it actually the case that left and right don't? Well, there we go. That one is left. So that's actually my left. So that doesn't look like I got that one right, did it? Alright, well, we'll fix that in a second. So, well, right does kind of work. It's a bit dodgy. Well, these two work nice. The other two don't. So it's a bit hard to tell whether or not that's just my terribly bad job at wiring things up. So this one here actually goes there. So why have I got that one wrong? Well, it doesn't matter. I don't really care. Because I just want it to work. So I won't be doing the soldering up for a little bit, but I might do that as a... I don't really want to do soldering because I'm not very good at it, and now it works a little bit better. So you can actually get 2 at once if you go in the... So if you go diagonally, that's how it works. So if I'm going diagonally, I'm going to light 2 up at the same time. So that one kind of works. It works enough that we can determine that it's fine. So now we have to add one more wire in. And where was that different coloured wire? Alright, well, we're going to use one of these ones for... This is slightly thinner wire. I don't know why I just don't use a different colour. I've got... Oh, well, we'll just use one of these. No, I can't. Okay, we're going to really go all out on getting the colours the wrong way around. So the positive is now going to be blue. It's a bit close up. So which one? Opening back up to our instructions here. I think I dropped the... I did, didn't I? Of course I did. Why would I not drop my bookmark? So positive is pin number 7. So I'll turn it off for a second. And so I'm hoping that this will actually show you the auto fire once this is hooked up. And then, how much time have we got? My goodness, that took 10 minutes. Like, I haven't done anything useful. This is the kind of stuff that I could have done off camera. Yep. I don't think we're going to talk about the potentiometer stuff today. Not until I actually find a pedal somewhere. And that's what they're called. I know it sounds like a weird name. And that one can just go straight into the 5 volt rail. And now we're going to turn it back on again. Okay, so that's the fire button going without me on N. I don't know what N is, so this is N and S. So I'm going to turn this one to S, and nothing happens. Well, that's not exciting. It doesn't seem to change anything. And now the other things don't work very well. What have I done wrong? It is a bit of a mess. Well, there's no point doing anything if I can't get it to... Have I got it to the right pin? Alright, let's just double check. So ground was 8, right? And 7 was the positive thing. I'm just going to double check. So I assume this is looking into the thing, into the watching. Where did I put that? So we're going to try this one more time. I really should have got the leads with the clippy bits on them, but they're in the other room. Alright, and I'm just going to measure the voltage. So if this is working, then the voltage between 7 and 8 should be 5 volts. Except it's not actually at 5 volts, it's at 3.3. I wonder if that changes how it works. My experience with 555 timers is that they do, it looks a bit better now. It's still not actually flashing. So it's supposed to flash with the auto fire. So let's just double check yet again that, I don't know how I'm going to do this. I'm going to turn this around. So fiddly. So I need to get these 2 pins and see what they say. Oh, it's not that hard, is it? Okay, bring this into view. So watch what happens on the screen. And no, I can't do this 2 things at once. Alright. Oh, there's so many wires here. This thing can move out of the way. How is anyone going to watch this video and find it interesting when it's all just a big mess? I've got it set to 2 volts, right? It's not an auto ranging thing, which is a good sign. So it does say 4.9. So we are putting the 5 volts out. But that's not working. So we're going to get the other joystick, which didn't even have an auto fire, but it's got a nice little switch on the bottom that tells you that auto fire is on. So the auto fire just simply worked by, look at that, when I put auto fire on, the light comes on, but it doesn't actually flash. And this one works in every single direction, real sweet. Look at that go. So that one's nice. It's rubbish when it comes to the fire button. Except you can switch it on with the auto fire. Alright, and we can go 2, 2. Just checking. Let's see. I don't have any other joysticks sitting around, so I can't test them with that. Well, that's a bit of a shame. Alright, well anyway, we're going to come back. We'll come back to that one. So hopefully we can get this to flash. I'm pretty sure that's all you need to do. It all looks right, doesn't it? So we will have to take the joystick apart and then test it. But the next thing we're going to do today, with our 10 minutes remaining, is we're going to get rid of this thing. And we're going to use a 9-volt battery directly. What did I do with the 9-volt battery I just had? I just took that off. It's right here. Okay. We're going to plug this in directly into here, but we don't want it to actually have 5 volts going into here. I mean 9 volts going into here. We want to get it down to 5 volts like we've got here. And the way I'm going to do this, so you could use a voltage regulator. So there's lots of ones, and the one that you normally use is the LM7805. Is like the standard kind of thing to use. Most people use these buck converters and boost converters and things, which are more efficient. But we're not going to go for efficiency. We're going to go for non-efficiency, because this is really a simple project, and who really cares how efficient it is, because you're only turning an LED on for a very short period of time. And in my final model, you're going to have to plug the 9-volt battery in to use it, and then you have to take it out when you're finished. It's not going to be stored on the inside because I don't want it to, it's going to be very rarely ever used, and I don't want to leave a battery in there, so it's going to have an external battery or external power source. But we're going to use, I think this is the symbol for it, a Zener diode. So we've talked a little bit about diodes before. So diodes basically sort of restrict the direction of the current into one direction. And we're going to use two types of diodes. We're going to use a normal diode over here. So initially I was just going to show you this. So this is your positive voltage and it's coming into here. And there's going to be a resistor here, and then there's going to be the Zener diode here, and then there's going to be the actual circuit over here. But we're also going to have it so that you have a diode in the way between the positive voltage and here, simply because in this case here, what happens if you plug the battery in the wrong way, it'll all damage the inside of the joystick. It won't damage anything else in the circuit, but it will damage the inside of it might damage the 555 timers inside of a joystick, so we don't want to do that. So we're going to have this as a protection diode, so it's only going to allow the current to go one way, so if you plug it in the wrong way, the circuit doesn't work. So we're going to have that one. But this one here, so a Zener diode does kind of work like a normal diode, so it only allows current in one way to a point. So if you put the current in the other way, it will inhibit the current from flowing until the voltage reaches a certain level, and then it will allow current to flow, but it will incur a voltage drop of a specific amount, and so they're designed to go for a specific amount. And I have these 5.1 Zener diodes here, so this is hopefully what it is. Hopefully I've marked this container correctly, because I won't have any luck reading what these things are. You can kind of read something on there. So you actually put these in the wrong way around, what the normal diode goes. So this black bit is the negative, or the cathode, I guess. I hope I got those terms right. Don't count me on this. But anyway, that's going to go towards the positive voltage. And so in this case here, you're going to need because this is a 5.1 Zener diode, you're going to need 5.1 volts to actually get past it. And because, if you remember your circuit stuff, if you have two parallel circuits, the voltage drop across each part is the same, and so this thing basically keeps the voltage drop equal over both parts of this. But you also need the resistor here to absorb the rest of the voltage. So this is going to keep the voltage across here being roughly about 5.1 volts or 5 volts, and this is going to take in the rest. So this has to be higher than 5 volts. So it could be like 7 volts or 6 volts. And then the leftover bits gets used up in here, and then we've got the rest of the circuit over here. So let's quickly make these things. So this is a really, really cheap and nasty way of doing a voltage regulator, or a voltage, reducing the voltage for your circuit. So what we're going to do is we're going to have, this is my first diode, so I'm going to put that one there, and then I'm going to take this thing here. So my positive thing, these, I don't know how well this is going to stick into here, it's going to go into there and not into the positive rail. So, but we are going to put the black one straight onto the negative rail, but we will have to link it up. Do I have any more wire? We do. So I'm going to get one of these, try and get a slightly better color. So I'm going to get a grey one, and I'm going to link the two negative rails, because I'm not actually using the negative rail on this side, am I? So I don't have to do that. Alright, so we're all going to concentrate, we do have to link the positive rails up. So we might as well do that with the grey one we just had. Because otherwise there won't actually be any electricity, and I put it over here on both sides. It will just be on the one side. So this will make sense. I'm going to run out of time to make this video, but that's okay. We'll just do a two-parter thing, a B part. Alright, so far we've got my 9 volt thing, so this is the negative going to there, and then we've got the positive going through the diode into here. So we've done this part of the circuit. I'm going to use a pretty low value. Where did I put my specific little resistor for this? I'm going to use a 100 ohm resistor. Not the best way of doing it, but it's a big chunky one. And that's going to be this part here. It's probably the worst thing. I'm going to chop off part of the legs with this tool, because I don't know where I put my pliers. Strangely, they're always disappearing. So hold on. Alright, and then and that one is going to go across like that. So now positive going into there through the resistor. And where did I put my Zener diode? And then we're going to split off the circuit. So here's my Zener diode, the little black bit. So the cathode is going to go into here, and that's going to go into, it's got to go into the negative rail. So at the moment there's only one negative rail. So I'm going to kind of cheat a little bit and bring it back over there. So it's a bit messy. That's okay. We're going to need, so that one is going, I hope this works, because if it doesn't, I don't know. Alright, and we've got that one there. So now we've done this part of the circuit, and then we've just got to connect up. So now our point, I kind of need one of these wires. We'll just use one of these, a nice red one. So at this point in here, so in between on this little line here, this rail here, is this point here in the circuit. So this little node, these are called, we'll call these nodes, and so I want that then to supply the positive voltage for the circuit. So if I put that there, so now that's going into the positive rail, and that's going to supply the other positive rail. So both these sides have positive rails, and we're going to turn it on and see if it works. But what we probably should do is we're going to take this resistor here. So this resistor here is doing nothing, but it's going across from here. It's in the positive rail to the negative rail directly. It's a 470 ohm resistor. But if this works, we should see about 5 volts going across here when we measure it with the whatchamacallit. Well, I don't remember what it's called. So we'll plug it in the correct way first off. Nothing's going to happen because we haven't plugged in a joystick. I hope I haven't broken something. I stood on this accidentally before I started, so that wasn't a very good start to the day. There we go. It's on now. We've got 1 minute left. Let's get this guy out again, and we're going to measure across. So hopefully you can see that. I'll turn the little light on, backlight, and then we're going to measure this, and hopefully it says 5.0 volts going across there. So it looks like it's working. So we've got our 9 volt battery, and now we're going to test this by just quickly turning it around, and which I should have just undid the wires, because I can't. It's not going to work, is it? Alright, I've got a whole pile of these. So I'm going to put this one onto there, and then I'm going to put that one onto the wrong one on here, and then I'm going to put the black one onto here, which is the wrong way around, and then the black one can go onto here. Sorry, I haven't got time. So now I put the battery on the wrong way, and if everything's working fine, then you should get 0 volts going across the resistor. So we'll just quickly test that because we've got 30 seconds, and then we'll call it a quits. So it should say nothing. So we do get no volts going across this resistor when we've got the battery plugged in the wrong way. So it's all looking good. We'll finish it off there, and thanks for watching. So like, share, and subscribe.